All right, so let's talk about the bonds that we can form with carbohydrates. So the ways that we can do this kind of gives the effector functions of the carbohydrates themselves. And the three most common reactants are alcohols, amines, and phosphates. So with the alcohols, this can be the alcohol portion, the OH group of, say, a sugar, or that of like a serine or threonine or some type of a hydroxylated group. We go ahead and call these things O-glycosidic bonds. O meaning obviously that of an alcohol. And then, so if we're really, so the product of this is called a glycoside. And that's an important term, I guess, in terms of clinical significance. Um, uh, digitalis, cardiac glycosides, things like that. The other one, though, would be amines, which is just that where we have linked by that of a, well, okay, so amines would be an N-glycosidic bond, and it's just that where the NH group of an amine comes in and then reacts that way. NH3R3 of that is the actual reactive species. We really tend to call these, somewhere in the name there's amino is in it. So like glycosaminoglycans would be an example of that. And then lastly, with phosphates, the only example that I could give that I think is really interesting would be that of, for example, DNA. Whenever it reacts with phosphates, it forms a what? The backbone of DNA is phosphodiester backbone connecting to a sugar. So for phosphates, it tends to form a ester linkage. And realistically speaking, this is the most stable one. Esters are really, really difficult to break.